What happens when entrepreneurship meets an idea? What happens when innovation meets best resources? What happens when manufacturing excellence meets latest technology? Topworth Urja and Metals Limited is part of the truly diversified Topworth group of companies headed by its founder chairman Mr. Abe Loda, a global entrepreneur and visionary leader. Under his able guidance and assisted by his highly competent team of professionals, the Topworth Group today is a global conglomerate with a key presence in almost all core sector industries across a wide range of business verticals like metals, mining, energy and power, agro products, infrastructure and pipes and tubes. Topworth Urja and Metals Limited is an ISO 9001, 14001, OSAS 18001 and BIS certified company which manufactures world-class TMT bars, having its brand name Loda Thermax TMT through its integrated steel unit, having its own sponge iron, steel melting shop, steel billets plant and a captive cogeneration power plant to meet the power requirements. This state-of-the-art plant, spread across a lush green campus over 200 acres, is located at Moza Ukawahi on Nagpur Umred State Highway, just 30 kilometers away from Nagpur, a vibrant city in the heart of the Vidarbha region in Maharashtra, India. The coal-based sponge iron plant was commissioned in February 2003, with the total installed capacity to produce 60,000 metric tons per annum. The process starts with the three main raw materials, which are iron ore lumps or pellets, non-coking coal and dolomite. These raw materials of required specifications and correct size are fed into the feed bunkers. Weigh feeders are installed to feed exact quantity of these raw materials in the right proportions into reactors known as rotary kilns, where perfect temperature profile is maintained by combustion of coal assisted by the air delivery via shell air fans. With excess carbon in the kiln, carbon monoxide is formed, which is the main reducing agent to get sponge iron from iron ore. This sponge iron is used as a clean feed material in the furnaces to make steel. The steel melt shop or billet plant consists of two induction furnaces of 12 tons each with a two-strand 6 by 11 meters continuous casting machine to manufacture 240 tons of billets per day, ranging from 100 square millimeters to 250 square millimeters cross-section. The capacity is soon being enhanced to 480 tons per day to match with the TMT bar mill's billet requirement. All raw materials and alloying elements to manufacture billets such as sponge iron, mild steel scrap, calcined petroleum coke, pig iron, silico-manganese and ferrosilicon are stored in the induction furnace sheds for further handling. Sponge iron is individually fed through weigh feeders for proper accounting, and the rest of the raw materials with alloying elements are fed into the induction furnace by getting it weighed in the platform scale. Scrap is charged by electromagnet. This process is followed by melting of the raw material mix, and the liquid metal with required chemistry thus obtained is tapped in a refractory-lined ladle and taken to the continuous casting machine to cast billets of desired specifications and correct chemical composition. The captive power plant was commissioned in July 2010 and has been operating at its full capacity of 30 megawatts since then. To scale up our total power generation, we have installed two additional power plants of 35 megawatts each, which will take our total power generation capacity to 100 megawatts. The steam is generated in atmospheric fluidized bed combustion boilers and additionally two waste heat recovery boilers installed in the downstream of the afterburning chamber attached to the rotary kilns in the sponge iron plant. These four boiler outlets are connected in the common steam header, and superheated steam supply is taken to the steam turbine. This turbine uses heat energy of steam to produce mechanical energy, which drives the alternator to generate electricity. Steam coming out of the turbine is condensed in the air-cooled condensers. The condensate produced is pumped back to the boiler via a deaerator, in which any traces of air is removed from the condensate. Essential controls and safety interlocks are provided, along with a distributed control system for smooth and automatic operation of the power plant. Modern fuel and ash handling systems are installed in this power plant to ensure neat and clean operations. Our Nagpur plant also has the most advanced TMT bar rolling mill, which can roll 150,000 tons per annum high-strength deformed ribbed steel bars of size 8mm to 32mm diameter. This TMT bar mill is very well equipped with reheating furnace, producer gas plant, 3 high and 2 high roughing mills, 12 numbers of finishing tandem mills, crop and cobble shears, pinch rolls, and fully automatic cooling bed. The finishing mills are driven by DC motors. Lodar Thermex TMT bars are rolled out in one of the most modern and fully automatic rolling mills, and further processed in the world-proven Thermex quenching technology from Germany to give high strength and superior quality TMT bars. The Thermex technology involves revolutionary 3-stage process of water quenching, self-tempering and atmospheric cooling. Thermex quenching technology rapidly cools the bar from the outside when it is still hot from the inside. Thereafter, as soon as the bar comes out of the quenching system, the heat at the core radiates to the outer surface to form tempered martensite on the surface, and the core of the TMT bar remains austenitic. Further, on the fully automatic cooling bed, atmospheric cooling results in the austenitic core to convert into ductile ferrite perlite core, which gives Lodar Thermex TMT bars their unique and unmatched qualities of strength and ductility. Our high-strength deformed steel bars are earthquake and corrosion resistant, strain-proof, highly flexible, heat-resistant, and have excellent weld and bend ability. Our stringent quality assurance department ensures that only the best TMT bars are rolled for our valued customers. In-house developed hot rolling is carried out for direct rolling of red-hot billets coming out of the continuous casting machine, bypassing the reheating furnace. This ensures negligible scaling of the billets and better surface finish of the TMT bars, and also fully eliminates heating and scale costs, thereby making our unit cost and energy efficient. Our global manufacturing standards, excellent CSR initiatives, perfect vertical integration of our businesses, cost-competitive synergy coupled with highly skilled human resources have made Topworth a name to reckon with. This is the continuation of our journey towards excellence, marching towards a brighter future.